Hello everybody, welcome again to the ETABS and SAFE course. Now we can begin with the design of columns. To do this, the design of columns, first of all, I want to unlock the calculation. Look the calculation because I want to define many sections of columns to use them, and the design of columns to try the section when we want to increase or decrease column. We will show this when we run the calculation. Now let's define some section of columns. For example, I want to define a columns with 803. Let's its name equal is F section 1, and then add copy. Let's define 900. We will show after why we define these sections. And let's define we press OK, then we press on the run analysis. Now ETABS has finished from the calculation. To facilitate our work, we design the columns and story 1, and we want to determine the section of the safety section of columns and story 1 because the story 1 bear the maximum load. When we determine the section of columns and story 1, we will apply this section for the other story. So we want to facilitate and to facilitate our work, we will select only the story 1. So we go to select stories. We select story 1 only, press select here, and we press here right click, show selected object only. We press here and deformed shape. Then we select all the story. We go to select, deselect. We go to object type. We choose beams, walls, floor, joint, and we press here deselect. Then we press right click, show selected object only. We do this thing to show only the columns and story 1. Then we selected the all columns. We go to design, concrete frame design. We go to the second option, view, revise, override. Here framing type we have sway special. That means that the column are included and the resisting of earthquake, but we use shear wall system, so the columns are not included and the earthquake resist. The columns and beams are included and resisting of earthquake if we use dual system or moment frame system. Now we use shear wall system, so the columns are not included and the resisting of earthquake. So we put here non-sway at framing type. We press OK, then we go to design, concrete frame design. We start the design of the columns. Now ETABS has designing the column. We show that the columns with red color are below the required section, and the columns with blue color are above the required section, are safe. So if we select this column and press right click and we go to summary, we go to the section properties. This is a summary sheet that said that this column is height equal to 600 with width equal to 250. We hear the rebar percentage. The ACI code said that the percentage of rebar of columns must be between 1% and 8%. So we have 2.69. It's a good percentage. Rebar area, we have the total rebar area mass and the columns equal to 4041. So 4041 divide by, if we use bar with diameter equals 16 millimeter, the area of the bars of 16 millimeter equal to 16 times 16 times 3 times pi over 4 equal to 201. So we divide by the total rebar area by 200y, which is the area of 1 bar 16. We get 20.10. So we have to put 21 bar 16, but we don't put into the columns an odd number of steel rebar. We put an pair number, so we put in the column 22 rebar of T16. Also, we can decrease this number by increasing the section of the columns to decrease the number of steel. We can try by press here on override is the column section. We put here F section 1. For this thing we define this section. We try here to put the column equal to, B equal to 800 and H equal to 300. We don't replace the section, but just here we try this section. So we show here that rebar percentage equal to 1% and the rebar area equal to 2400. So we need, if we do 200 divide by 201, we need to 12 bar T16. So we go to the AutoCAD file, we draw the columns with the section equal to 800 by 30. We put here 6 rebar 16 and 6 rebar 16. This is just a shop drawing. We must draw the columns with a section and put 6 rebar by 6 rebar to draw the shop drawing of this column. This is for the columns, for the corner columns. So we show that the section 800 by 3000 is the best section for the corner columns. For edge columns, we press here and press right click summary. We show that this column is over strength, so we must replace this section and we try other section. Let's put the F section 4 and we try it. We go to summary. Now the percentage is 1%. Can try with another section to be economic. Just here to learn, we want to learn how to design the columns. So the rebar percentage equal to 1%, the rebar area equal to 3300 divided by 201, we need to 17, so we put 18 T16 bars. For the middle columns, let's try the F6. We go to summary. We have percentage equal to 6%, so we must increase more this section of the middle column. So we can go to unlock the calculation. We put here all stories. We choose the corner columns and we put assign frame section. We choose F section 2 for column. For each column we select them, assign frame, and we put F section 4. Now we will to try, want to increase this section. Let's increase by like this, and let's apply this section to this column and we will try. We can show the increases of column and the plane. We can show that we increase the middle and corner and and edge columns. So now we can run the calculation to check the design of the columns. The ETABS has finished from the calculation. We can now select the column of story 1 and go to design, start design, and check to check the columns. Now we go to the middle columns. We go to summary. We show that we had the percentage rebar equal to 1% and the total area of rebar equal to 9,000. So we are safe for the middle column. For each column also we have rebar equal 1% and total rebar area equal to 3,300. And here we have 1% rebar for corner columns and total rebar area equal to 2,700. So we has finishing from designing the column, and we apply the section for other story for columns because other story. Thank you for listening. We will continue the work in the next lectures.